Hello everyone, I had the very rare opportunity to tour a wastewater treatment plant. Quick disclaimer, all the images shown in this video are shown with permission, and nothing related to on-site security will be shown or discussed. I also won't show any excessively gross pictures. Keep in mind that I am not an expert on this, and there may be a few incorrect details. The tour was very fast-paced, so I apologize if some of the photos are at an awkward angle or in portrait. I won't disclose the exact location of this facility, but I will say that it's in central Oklahoma. It serves around 60,000 people and can treat 12 million gallons of sewage per day. That's enough to fill 20 Olympic-sized swimming pools. The sewage comes in through here. This picture doesn't convey the scale very well. This pit is enormous. I don't know the exact diameter of those pipes, but I do know they are several feet wide. Sewage then goes through screens to remove trash, which is collected in those dumpsters and sent straight to the landfill. Quick reminder, don't flush anything that doesn't break down easily in water. So no grease, floss, tampons, etc., and especially wet wipes, even if they say they are flushable. Those items cause so many blockages, and your tax money goes into fixing those. The sewage is then pumped up and flows through the rest of the plant through gravity. They also have two lined holding ponds, so if there's too much inflow for the plant to treat, they can pump the excess in there. This usually only happens during bad storms. The city has a municipal separate storm sewer system, which is just a fancy way of saying that the storm drains on the streets go straight to the river, and this plant is only for the sanitary sewer. However, a significant amount of rainwater leaks into the pipes. Anyways, the next step is grit removal. This removes grit, which is sand and gravel, from the water. It settles out here and is collected by a conveyor belt and goes into a dumpster. Next we have the primary clarifiers. As you can probably imagine, it smells absolutely awful in here, which is why these are enclosed. We'll go into more detail about how these work once we get to the secondary clarifiers, which are identical but are outside. These remove organic solids, such as poop, from the water. These can remove grit too, but the grit removal is done before to keep it separated from the organic solids, since they are recycled and used to make fertilizer, and the grit is sent to the landfill. This removes the solids, but there are dissolved nutrients in wastewater which can cause excessive algae growth in water bodies. To remove that, we use a moving bed biofilm reactor, or MBBR. This has these plastic things called media with bacteria on them that consume the dissolved nutrients. They are aerobic bacteria, meaning they need oxygen to survive, so the water has to be aerated. This produces solid sludge, which is removed in the secondary clarifiers. These are the same as the primary clarifiers shown previously, but they don't smell as bad, so they're open to the air. One of them is drained for maintenance, so we can see how it works. Water enters in the middle and flows over the weirs at the edge and moves to the next step in the process. This slows the water down enough for solids to settle out. The arm in the middle spins around and collects the sludge at the bottom, and the skimmer removes floating scum from the surface. Some sludge is sent back to the MBBR to sustain the bacteria, and the rest is sent to the digester. More on that later. The last step in the process is disinfection. This plant uses ultraviolet C or UVC light. As you can see, we have 3 rows of 4 units, with each unit having 40 165 watt lamps, so that's 79,200 watts of UV lamps in total, not even including ballast losses. In the background, you can see the cabinets that supply the 480 volts these run on. Here's a close look at that. I'll go into more detail about what these numbers mean when we get to the main electrical service. They have equipment that measures the power draw and sends that information to the Supervisory Control and Data Acquisition, or SCADA system, which is used to operate the facility. If the power consumption drops, a notification shows up in the control room indicating that the bulbs need to be replaced. In the center of the room, they have a small crane so they can take the units out to change the bulbs. They also have a spare unit so they can swap the burned out one with this one and then replace the lamps in order to minimize downtime. After the UV, the water flows down this cascade into a creek. The purpose of this is to aerate the water to ensure that there's enough oxygen for fish. Here's where it flows out to the creek. This facility uses a fair amount of water for its own processes, and almost all of that comes from the effluent, which is the treated water that is released. These are the pumps that supply it, and they're in the UV building right next to the lamps. All of the reclaimed water pipes are purple, so they're not accidentally confused for potable water. The fire hydrants are also fed from the reclaimed water, and maybe the fire sprinklers are too. I could be wrong on that though. In this photo, we can see the transformers that power this facility. I don't know exactly what the kVA is on these, but I know it's a lot. These convert the 12.47 kilovolts in the utility to 480 volts. It's a Y-connected system, so it's 480 volts phase to phase and 277 volts to ground. The box on the left is a huge backup generator, just in case the plant loses power. All critical systems are connected to uninterruptible power supplies, or UPSs, because the generator takes time to start up, so there's a slight delay from when the power goes out to when it switches to the generator. Here's the label for the switchgear for these transformers. Again, I don't know how much power this equipment can supply, but I know it's probably in the megawatts, and I don't even want to imagine what the available fault current is. As you can see, we have an incident energy of 78.7 calories per square centimeter if there is an arc flash, which is basically an electrical explosion. 78.7 calories per square centimeter is pretty much unsurvivable unless you have a really good arc flash suit. This doesn't even power the whole plant. The pump house uses so much power that it has its own dedicated transformer and generator. This is the sludge processing equipment. They thicken the sludge and send it to the digester, where bacteria break down into biosolids, which are then dried, disinfected, and sold as fertilizer. This uses anaerobic bacteria that don't use oxygen, unlike the MBBR, which uses aerobic bacteria. They also have their own on-site testing laboratory, where they test the effluent to make sure that there are no issues and that it complies with all regulations. While water treatment plants do a pretty good job at removing harmful stuff from wastewater, they aren't perfect. Chemicals and pharmaceuticals that pass through the human body are not removed and can be found in effluent in trace amounts. The effects of this are not well understood, but some studies, which I'll link in the description, show that those chemicals have a noticeable effect on wildlife. A study by the U.S. Geological Survey found that fish downstream of wastewater treatment plants had elevated levels of antidepressants in their brain tissue, while fish upstream did not. This caused them to be slightly more timid than they normally would be. In the future, we may see new processes to remove these chemicals. I hope you found this video interesting. Bye.